Hello students, welcome to a series of additional mathematics program for grade 10 and grade 11. The topic for today is binomial theorem. This is the second lesson on binomial theorem. The learning objective for today's lesson is how to use the binomial theorem for the expansion of a plus b to the power of n for any positive integer value of n. The prior knowledge for this lesson, so you should be familiar with expanding products of algebraic expressions. You should also know how to manipulate simple algebraic fractions. You should know about the Pascal's triangle and the binomial theorem. You will recall that in the first lesson, you had learned about the meaning of NCR, that is, NCR equal to n factorial over n minus r factorial times r factorial, and NCR can be evaluated using the calculator. This is the binomial theorem, the formula for binomial expansion. A plus b to the power of n is equal to a power n plus nc1, a to the power of n minus 1, b power 1, plus nc2, a to the power of n minus 2, b square, plus ncr, a to the power of n minus r, b power r, plus plus n, b power n, where n is a positive integer. So let us look at this example. Expand 1 plus x to the power of 4. Using the formula, a will be equal to 1, b will be equal to x, and n will be equal to 4. Replacing in the formula and simplifying will give us 1 plus 4x plus 6x squared plus 4x cubed plus x to the power of 4. Now we are going to see how we can use the binomial theorem in different examples. So the first example, part A, write down the first 4 terms of the expansion of 1 plus x to the power of 7 in ascending powers of x. Part B, use these terms to find an approximate value of 1.01 to the power of 7. Now, part A, it's quite simple. We are going to use the formula. So A is going to be equal to 1, B equal to x, and n equal to 7. Replacing in the formula and simplifying, we shall obtain 1 plus x to the power of 7 equal to 1 plus 7x plus 21x squared plus 35x power 3. Remember, we have been asked to find the first 4 terms only. Now part B. I need to find the value of 1.01 to the power of 7. So here you can see that we have found the expansion of 1 plus x to the power of 7, and we need now to evaluate 1.01 to the power of 7. So we are going to let 1 plus x be equal to 1.01. So x will be equal to 0.01. So we shall have 1 plus 0.01 to the power of 7. What we are going to do now is we are going to use this line And wherever we have x, we are going to replace it by 0.01. So 1 plus 7 times 0.01 plus 21 times 0.01 to the square plus 35 times 0.01 to the cube. And using your calculator to evaluate this, you will obtain 1.072135. Second example, part A, expand 1 plus y to the power of 5 in ascending powers of y. Part B, hence find the expansion of 1 plus x squared to the power of 5 as far as the term in x cubed. So part A is quite simple. We just have to replace in the formula. So here A is 1, B is going to be equal to y, and n is equal to 5. So replacing in the formula and simplifying will give me 1 plus y to the power of 5 equal to 1 plus 5y plus 10y squared plus 10y cubed plus 5y to the power of 4 plus y to the power of 5. Now for part B, I need to find 1 plus x squared to the power of 5, and I need to find up to x cubed. So you can see that we're going to use the answer obtained in part A to do part B. So here let 1 plus y be equal to 1 plus x squared. And y will be equal to x plus x squared. So we shall replace y by x plus x squared everywhere in this line. So 1 plus 5 into x plus x squared plus 10. Instead of y squared, we write x plus x squared to the square plus 35 into, instead of y cubed, we write x plus x squared to the power of 3. Because we have been asked to find up to the term in x cubed, I have not considered these two terms. Now, simplifying, I will get 1 plus 5x plus 5x squared plus 21 into, so here I have to expand, I will get x squared plus 2x cubed plus x power 4. Remember, we have learned in the first video, a plus b to the square is equal to a squared plus 2ab plus b squared plus 35. Now here I'm going to consider only the first term, that is x cubed. Again, this is because in the question we have been asked to find as far as the term in x cubed. So expanding the brackets and adding the like terms will give me 1 plus 5x plus 26x squared plus 77x cubed. Example 3 now. Find part A in ascending powers of x, the expansion of 1 plus 2x to the power of 3 and 2 plus x to the power of 4. Part B, hence find the first 4 terms of the expansion of 1 plus 2x to the power of 3 times 2 plus x to the power of 4. So now I'm sure you can easily do part A. 1 plus 2x to the power of 3. We replace in the formula. So here A is going to be equal to 1. B is going to be equal to 2x and n is equal to 3. Replacing in the formula and simplifying will give me 1 plus 6x plus 12x squared plus 8x cubed. 2 plus x now to the power of 4. So here a is equal to 2, b is equal to x, and n equal to 4. So we replace in the formula and we simplify to get 16 plus 32x plus 24x squared plus 8x cubed plus x to the power of 4. So this is for part A. Now for part B, we need to expand 1 plus 2x to the power of 3 into 2 plus x to the power of 4. So we shall use the two answers obtained in part A. And here I will have to expand these two brackets. So 1 will be multiplied by all these terms. 6x will need to be multiplied by all these terms. Similarly, 12x squared multiplied by all of them. 8x cubed multiplied by all of them. But remember, in the question, we were asked to find the first 4 terms. So I'm going to ignore terms including x power 4. Expanding the brackets will give me 16 plus 32x plus 24x squared plus 8x cubed plus 96x. Now you will see that I have written the like terms one under the other so that it is easier for me to add. Plus 192x squared plus 144x cubed plus 192x squared again plus 384x cubed plus 128x cubed. So now we need to add the like terms. And this will give me 16 plus 128x plus 408x squared plus 664x cubed. The next example, find first part in ascending powers of x, the first 3 terms in the expansion of 2 minus 3x to the power of 5. The first 3 terms in the expansion of a plus bx into 2 minus 3x to the power of 5 in ascending powers of x are 64 minus 192x plus cx squared. Second part, find the value of a, b, and c. So now you can easily find the first 3 terms in the expansion of 2 minus 3x to the power of 5. Replacing in the formula with a equal to 2, b equal to minus 3x, and n equal to 5 will give me 32 minus 240x plus 720x squared. Now for the second part, we have been given that a plus bx into 2 minus 3x to the power of 5 is equal to 64 minus 192x plus cx squared. So from part A, we have already obtained the first 3 terms of this expansion. So replacing it, we get a plus bx into 32 minus 240x plus 720x squared, which is equal to 64 minus 192x plus cx squared. So we need to expand the brackets. to get 32a minus 240ax plus 720ax squared plus 32bx minus 240bx squared. So I'm not going to consider this one because I'll get x cubed, which I don't need, is equal to 64 minus 192x plus cx squared. So grouping the like terms, we shall obtain 32a plus x into minus 240a plus 32b plus x squared into 720a minus 240b equal to 64 minus 192x plus cx squared. So now we are going to compare the constant terms. So 32a equal to 64, and solving this equation we get a equal to 2. We now compare the coefficient of x. So minus 240a plus 32b equal to minus 192. We have already obtained the value of a. So we replace the value of a here. We get 32b equal to 288. So b is equal to 9. We now compare the coefficient of x squared. 720a minus 240b equal to c. So now the values of a and b are known. So we replace these two here and we obtain c equal to negative 720. So now you have a few questions for you to practice. They are quite similar to what I have just explained. Number 1, the first three terms in the expansion of 1 minus x over 7 to the power of 14 into 1 minus 2x to the power of 4 can be written as 1 plus ax plus bx squared. Find the value of each of the constants a and b. Number 2, write down the first four terms in the expansion of 1 minus x to the power of 8 in ascending powers of x. Using these terms, find an approximate value of 0.99 to the power of 8. So here, remember you need to use the formula to find the first four terms, and then you equate 1 minus x to 0.99 to obtain the value of x, which you then replace in the expansion. Question 3, part A. Expand 1 plus y to the power of 7 in ascending powers of y. Part B, you need to find the expansion of 1 plus 2x plus x squared to the power of 7 as far as the term in x cubed. Number 4, you need to find the expansions of 2 plus x to the power of 6 and 2 minus x to the power of 6 to be able to find the exact value of 2 plus square root 5 to the power of 6 plus 2 minus square root 5 to the power of 6. So here, your knowledge of surds is very important. Number 5, part A, you need to write down the expansions of 1 plus 2p to the power of 5 and 1 minus 2p to the power of 5. Part B, you need to use your answers to part A and subtract. And part C, you need to use the answer to part B to find part C. Similarly, you have two more questions. question 6 and question 7 to work out. You also have some links where you will get additional information on what I have just explained to you. You also have some worksheets where you can get additional practice. So students, we have reached the end of this lesson, and in today's lesson, we have learned how to use the binomial theorem for the expansion of a plus b to the power of n for any positive integer value of n. I would now advise you to practice these concepts by working out the questions found in your textbook. You can seek the help of your teacher or your parents or even your friends in case you have any problem. So until we meet again for the last part on binomial theorem, it's goodbye from me.